purpose of this video is to help you get started with worksheets A, B, and C in step 19, or check your work if you've already done them. So here we're talking about exponential functions, where x is in the exponent. So if we look at example 1, we have y equals 3 to the x as our equation. So if I type in y equals 3 to the x power and graph it, I can pull up the table to see these values that they have in the table. If I look at the equation, I can tell that it's growth because 3 is the base of the exponent and 3 is greater than 1. So it's going to make the exponential, it's going to make the function grow over time. If we follow the graph from left to right, we can see that as we follow it, the graph is increasing from left to right. The y-intercept we can find from the table where x equals 0, or we can find from the graph by going to second trace number 1. We want the y value when x equals 0, and we get 1. The domain is all real numbers. The domain is always all real numbers, which means negative infinity to positive infinity for exponential functions. We can sub in any number we want to this function. There are no restrictions. And the range is always going to go off to infinity, but the starting value in the range is not always the same. In the parent function, it starts at 0 and goes off to infinity. So in this function, it's all positive y values. There's no x value you can sub into this function and get a negative y value. Therefore, the range, all the y values, all the outputs in this function go from 0 to infinity. If we look at example 2, we can see that this is going to decay because the base of the exponent is 1/4, and that's between 0 and 1. We can find the y-intercept from the table or the graph. Again, the domain goes from negative infinity to positive infinity, and the range goes from 0 to infinity. So when we graph these functions, you just need to find a couple points, sometimes only one, and then just graph it. Just give it a good estimation. Doesn't have to be perfect. On your assessments for this step, you will not be graphing by hand. It'll be like the last assessment where it was multiple choice. You had to choose the correct graph. So if we look at first looking at growth and decay, we have to look at the base of the exponent. So here the base of the exponent is 0.3, which is between 0 and 1, which is why this function decays, decreases over time. And number 2, the base of the exponent is 3, which is greater than 1, therefore it grows over time. The base in number 3 is 1/3, which is between 0 and 1, therefore it's going to decay. The y-intercept you can find from the table or the graph. Again, noting the domains are all negative infinity to positive infinity. That will always be true with exponential functions. Now the range, the range comes from, and it creates a horizontal asymptote. We talked about asymptotes in the last section. So in this original function, we're not adding or subtracting a constant. So the horizontal asymptote is at y equals 0, because the graph is going to level off at 0, but it's never going to cross 0. It's never going to be negative. So the range, the y values go from 0 off to infinity. Now, if we look at 2 and 3, both of them have a +1. We have the exponential +1 as our constant. So y equals 1 is the horizontal asymptote in both of these graphs. So the range goes from 1 off to infinity. The smallest y value it will ever be is 1. And then there is no largest y value. That's why we put infinity. It will continue to grow, or it will continue to decay. All right, now let's go over and look at worksheet B. So we're still graphing exponential functions. The parent function is y equals a times b to the x power, where a is the y-intercept, b is the base of the exponent, and the base determines growth or decay, whether the function is going to grow or decay. So we're going to state the transformation of each equation, and I just am looking for up, down, left, and right. We're not going to do stretches or reflections. We're just looking for up, down, left, and right. We're going to graph each function, which you can use your calculator and graph each function and state growth or decay for each equation. So in 1, 2, and 3, I have the base highlighted. In 1 and 2, the base is greater than 1, so that function is going to grow. In 3, it's 0.5, which is between 0 and 1, so it's going to decay. There's no up, down, left, or right transformation, so you can use your calculator and graph. If we look at 4, 5, and 6, again, I have growth and decay highlighted and written in green. And then these are transformed up, down, left, and right. So the -8 after the function in number 4 will move the whole graph down 8. So the range here will go from -8 to infinity. I know I didn't ask for the range, but I'm going to write it anyway for practice. In number 5, see how the number is right next to the x value? That's what moves it left and right, and it's always opposite of its sign. So this is going to go right 3. Here, the function didn't go up or down at all, so the range is going to go from 0 to infinity. And in number 6, we have 2 transformations. The x plus 4 will move the graph left 4, and the -5 from the entire function will move it down 5 units. So since it went down 5 units, the range will go from -5 off to infinity. Seven, 8, 9, and 10, there are no transformations, so just do parts B and C. And let's look at worksheet C, where we start solving exponential equations. So I clipped this chart from our notes. That way it was just easier to access. So remember the steps when solving an exponential equation. Steps are find a common base, set the exponents equal to each other, and solve. So in number 1, I have base 4 and base 64. I turned 64 into 4 cubed. Because 64 is equal to 4 cubed, and I brought down everything else. That's all I changed in the first step. 64 to 4 cubed. Now the exponent rules say that if we have an exponent raised to an exponent, so this is power rule, we need to multiply exponents. So that 3 gets multiplied by x minus 3, so we distribute the 3. So I have 4 raised to the x plus 35. This side hasn't changed at all yet. That's just come down. Here I changed the base and multiplied the exponents. So now I'm going to set the exponents equal to each other, step 2, and then solve. Divide by 2 as the last step to get x equals 22. And then you should use your calculator to check your work. So if I got x equals 22 as my solution, I'm going to type in 22 and I'm going to store it as x. And now I'm going to type in the original. The left side of the equation says 4 to the x plus 35. And the right side of the equation says 64 to the x minus 3. Both sides equal the same number, therefore this is the solution to this equation. Number 2 was quite easy because we already had base 25 on both sides. So step 1 was already done, and we went straight to step 2, setting exponents equal to each other. Step 3, solve. So you can pause this while you're working through 3 and 4, or check your work. We're just going to scroll through the rest of these slowly. I started these for you and getting a common base. But you still need to solve. Same thing with 7 and 8. Found the common base, you can solve.